Hey everyone, welcome back to the channel. The master is back and we are starting unit 2. That's right, we are now in the second unit of college algebra unit 2. We're going to be taking a look at using the midpoint formula a little bit, getting yourself familiar with that, and using the distance equation, which I'm going to explain to y'all once you start doing some of the problems. You already know some of the stuff, you know, if you're taking geometry, maybe some algebra. It shouldn't be like I've never learned this before, so it's kind of a review for this is mainly just a review for the rest of the stuff we're going to be doing in unit 2. All right, so hope y'all are doing well, and let's get started. All right, so basically, as I told you, yeah, we're going to be doing problems involving the distance formula and just other stuff in general. Nothing too out of the blue here. So I'm going to click key opened up on the right, and hope y'all are doing great so far. If you've understood what I've been doing so far, just let me know down in the comments below what y'all have thought about unit 1 and how y'all did. Alright, here we go, unit 2. Starting things off pretty simple and should just mostly be a refresher, alright, in this video. So first of all, let me explain to y'all, make sure the recording tool is working properly. Y'all can see this board. Good. Alright, we shall be set then. So I'm going to explain to you a little bit about coordinates, points, the quadrants. So that's one thing we need to get out of the way. So let me draw something right here. Let me draw this. That was horrible. Trying to draw a coordinate system. Imagine this, right? And if you guys do know by now, this is quadrant 1, quadrant 2, quadrant 3, and you guessed it, quadrant 4. You may know this by now, but just understand this so far. We're not trying to do any high-level thinking yet. And you'll know, okay, this is the y-axis right over here, and this is the x-axis, right? When we refer to it, you can think of it as a coordinate system with graphs and points. You can imagine it like this, right? And you can draw lines on this and graphs and whatever you want, you know. So you understand this pretty well by now, right? Here, everything is positive, x and y. This is the positive side. This is also the positive side. Here in quadrant 2, the y is still positive because we're still above the x-axis. But here the x value is negative in quadrant 2, right? In quadrant 3, not only is the x negative, the y is also negative. And in quadrant 4, the x is positive, but the y is negative, all right? So if you can kind of understand that so far, you'll do that. All right, let me ask you a question. You can pause the video right here. This point, 1, -6, all right? What quadrant is it in? Is it quadrant 1, 2, 3, or 4? I'm going to pause the video. All right, so according to this, we have a positive 1, so we're on the right side, and then -6, so we're down somewhere here. So I think our point will be somewhere along here, right? In quadrant we are in quadrant 4, right? So you can think of it going as 1, 2, 3, 4, back to 1. So you may call this anti-clockwise, right? It's also, if you learn in physics about torque and rotational motion, going in the anti-clockwise direction, all right? So yeah, if you can understand that, then you will do good. You can also look up quadrants, coordinates, points on your own. But if you kind of understand it like this, you'll do fine. There might be some other videos and tools out there for y'all to understand quadrants, but they should be pretty simple, all right? If you can understand it like this, then you'll do awesome, all right? That's kind of the starting point for where we're going with this, all right? Let's go ahead and take a look at an actual problem. Right, so I'm going to go ahead and erase this, but I'll draw more of these so y'all can clearly understand what's going on, alright? It's time for some fun, y'all. Eraser, here we go. Alright, so let's take a look at this, alright? We have this equation, y equals 3x minus 10. Alright, this is our equation. And they're asking us, here's a question for y'all. If x equals 6, right, what is y? And we're like, oh, this is easy, right? And we just plug it in here, right? So 3 times 6 minus 10, all right? That's 18 minus 10, that's 8. So if you want to write it as a quadrant point, it'll be 6, 8, 6, 8. All right, y'all? So yeah, that's basically it. Okay, and you can kind of draw it out like this. It's quadrant point 6, 8, something like around here, and we'll have a point 0, negative 10 around here, and then a slope of 3. So 1, so rise 3, run 1, right, rise 3, run 1, something like this. Connect the points as best as you can, something like that, right? So yeah, that's basically this problem, right? So let's go ahead and kick this into a higher gear. Not really, but give you another equation, and I want to do this one with y'all. All right, I'm gonna do the hard problems on your own. All right, I'm just kidding. So this time I want you guys to find the x-intercept. You should know what that means. Basically, the value of x and y equals 0 for this equation right here. 8x plus 4y equals 32. Go ahead and find, pause the video, go ahead and find the x-intercept. Alright, so you've done that, and I literally told y'all that's when y equals 0. So 8x equals 32. Now go ahead and make sure it's in coordinate point form. So yes, x equals 4. So your answer is 4, right up here, 4, 0. That's your answer. That's the x-intercept. Alright, pretty easy enough. Alright, let's go ahead and talk about distance now. Alright, since I'm pretty sure we've all mastered this concept. Let's talk about distance a little bit. The distance formula is basically, and I'm gonna use some text first of all. Make it all fancy right up here. Let's make this some big and bold text. Alright, the distance formula. Just like that. And I'm gonna write it out now. Alright. Is this. So I'll make a down arrow. Signify that it's down below. There we go. The square root of, and this distance between any 2 points. So let's say you have a point x1, x1, y1, and we have another point x2, y2. No, it's like that. How do you find the distance? Well, it's nothing but, I'm think of it as x2, nope, x2 minus x1, all that squared, plus y2 minus y1 squared, and the square root of that. That is the distance formula, alright? The distance between any 2 points. Alright? So let's go ahead and practice that. Here's a point, 0, 0, aka the origin of the graph. And another point is 12, 12. Alright. So let me ask you guys a question. You can pause the video and think about it if you want. Is the distance between these 2 points 12? Pause the video, let me know. I think it is, or if it's not, what is it? Alright, pause the video. Alright, so is the distance actually 12? Well, let's find out. Before we get to that, I'm going to draw a little graph for us. So we're finding the point between 0, 0, and we'll say this is 12. It's not the scale, so don't judge. And this is 12. So 12, 12 will be somewhere around here, right? So we want to find this distance. You can tell this is 0, 0. So the question is the distance 12? Well, some of y'all may think, okay, let's think about it like we make a little right triangle. I can make a good straight line here. We'll say, okay, this is 12, and this is 12. So the distance formula is kind of like the Pythagorean theorem in some sense, right? It's kind of like finding the hypotenuse in a triangle. But it doesn't have to be a right triangle always. Like in this case, it's nice and neat that distance from x and y is both the same. It doesn't have to be. But essentially it is, sort of somewhat, making a right triangle and finding the distance between them, right? Yeah, so it's x2 minus x1 squared plus y2 minus y1 squared. Use Pythagorean theorem or the distance formula, which is pretty much the same thing. And it'll be, well, 12 minus 0 is 12. So 12 squared, talking about the x distance. The y distance is also the same. The difference between the 2 points is 12 squared and then it's the square root of all of that. Alright, so I'll write it up in here. It's the square root of, well, 12 squared is 144, so 144 times 2, 288. Square root of 288. Alright, and we can simplify that. I'll do that part right here. So 288, I believe, if you find some of its factors, you can do 288 divided by 16, and I think by 9. Alright, so it's the square root of 16, then 9, and then times 2. So the square root of 16 is 4. Square root of 9 is 3. We're just left with the root 2 over here. So this is equal to 12 root 2. So it is not 12, it is 12 root 2. Alright. If you also know, y'all, this is a right triangle, and you know this is 12 and this is 12, and this is a 45-45 right triangle. Alright? Because you know these two sides are the same. So the equation for that is n and n root 2. If you know this Pythagorean or this trigonometry rule. So if you know this is 12, just by knowing if it's a 45-45-90 triangle, if you know one of the side lengths, you know that the other side length will also be 12, and your hypotenuse will be 12 root 2. So yeah, essentially we proved it solving it both ways. Alright? So just giving you all multiple ways to solve these types of problems. Whatever works best. Alright. Let's take a look at another question. Here. Okay. Let's go with more midpoint related stuff, alright? Point P has these coordinates. Alright. Has the coordinates 13 and -5. Point Q has the coordinates 18 and 0. This is a comma, y'all. This isn't P1 or something. I bet a straight line apparently. Okay, and I want us to find the distance between points P and Q. Alright? The distance. Not coordinate P and Q, that would make no sense at all. Find the distance between the two. Alright, let's go ahead and do that. Well, let's see here. So according to our formula, the distance, so we can do 18 minus 13, well that's 5, squared, plus 0 minus 5, well that's also 5 squared. Again, and then in root 2, the distance between them is 5 root 2. So 5 root 2 is the distance between the 2 points. You can use the distance formula to solve it, but this is a simplified way. And let's say we want to find the midpoint. Midpoint, point M, is between these two. So let's kind of think about it like that, alright? If you have 13 is over here, -5, somewhere around here. This is point P, alright? Point Q will be 18, 0. So again, 18 will be, drag this out a bit, 18 here, right here. Is point Q. And if you draw somewhat of a line between these 2 points, something like this, right in between them is point M. What are the coordinates of point M, the midpoint between point P and point Q? If you're taking geometry or just no basic math, it's honestly just the x distance is in between, the y distance is in between. So 18 minus 13, we said that was 5, so the half of that distance is 2.5. So you can think of it as 18 minus 2.5, so 17, 16, 15.5. That's your x distance. Your y distance, well, you know, that's also 5, that'll be minus 2.5. So these are the coordinates of point M. Alright, our midpoint. Right there. Alright, and that's it. Memorize it, y'all. Got it. Again, not too calculus level or anything, just some basic math, alright? So, let me all ask you some questions about, okay. That's all a question. It's not a trick question or anything. But let's say we have these points, 0, -6, that's a comma, I'm just making it look like a straight line. -3, -17, comma, 2, 2. Alright. My question is for y'all, pause the video. Are these 3 points collinear? Alright, pause the video to figure it out. Alright, so if you want to pause the video, either you know the answer, you don't know what to do, boom, explain. Collinear basically means this. If you have a point here and a point here, and then you draw a line between them, that's horrible. That, even worse. I cannot make, y'all cannot draw a straight line on this thing. And let's be at this point. The question is, are all 3 points on the same line? Meaning, are they in the same equation? Do they all have the same slope, and will they all fall on the same line? Well, let's look at this. And just by sort of a, you're looking at it, 0, -6. Let's say it's somewhere here. Not bad. 0, -6 would be here, right? So let's say this is point 1. Point 2 is -3, -17. So -3 would be here, and -17 would be way down here. And 2, 2 would be 2, 2, somewhere around here. Just by looking at it, you can tell they aren't the same. Hence, you can find the slope and all, but no. These points are not collinear. So the answer, I know I got rid of one of the points, but the answer is no. Alright, I'm going to get rid of everything. Control Z is fun. Alright. But not the computer racing. I don't know I'm saying Control Z. I'm on a Mac. I should say Command Z, but whatever. Okay, let me ask you a fun little question. It's pretty goofy. These points. 7, 1, 0, 5. Ooh, 0, 5. And -6, -8. Do they form a right triangle? I'm going to give you all 3 seconds to answer this question, because the answer is a no. Alright, that's it. Those were the things I wanted to cover, but I don't want to spend too much time. Just knowing what things make right triangles are important. But most of the time they won't be, but just confirm it. Just check the points and everything, y'all. Alright. I have another point. -12, -6. And then a point. I'll write it down below here. Or actually, no, wait. Make it like this. So we have a point, right? -17 and 2. Our midpoint right over here is -12 and -6. What are the coordinates of the other point? Well, we know this distance is 5, so this will be 5 less. So, -7. And from 2 to -6, we went 8 less. Now we'll go another 8 less, -14. This is our other endpoint right here. Alright? Got that? Okay. Alright. Let's try something a bit harder. I definitely want to pause the video and try this one out first. Point M has the coordinates C and N. Point Q has the coordinates H and S. Alright, what are the coordinates of, wait, hold up. Yeah, M is the midpoint, and this is, so this is a midpoint, all right, midpoint here. Q is an endpoint, all right, over here. We're going to find the coordinates of the other endpoint, all right? So how do we do that? Well, if C is our midpoint, let's say our other point we're looking for, let's call it as XY. Those are the coordinates of our missing point, all right? The other endpoint, all right? Well, we all know that C will be equal to coordinate H plus coordinate X, and then divided by 2, right? It'll be halfway in between them, right? Like, let's say we have 5 and 7. 5 plus 7 is 12 divided by 2 is 6, and 6 is in between 5 and 7. So if you think about it like this, so if we cross multiply by 2 on both sides, we'll get 2C equals H plus X. So X equals 2C minus H. And just by that deductive reasoning, Y equals, you can calculate yourself, 2 times N minus S. Don't care about that, y'all. So there we go. It's 2C minus H, comma, 2N. 2N minus S. Just like so. Alright? Got that? Good. Good, good, good. Couldn't be better. Alright. Let's go ahead and see. Is there anything else we need to cover? I think this is a good stopping point for now. Almost, maybe. That shouldn't matter. A couple more, and then I think I'll end the video. Right, so let's say, and that's all question. You have this point, right? I'm going to draw it out. -6 and 3. Alright. -6 right here, and 3 is up here, alright. -6 and 3. Alright. At one point, will it intersect the x-axis? The x-axis. This is the x-axis, right? The x-axis. So that's basically whenever something intersects the x-axis, y equals 0. So if I draw boom, never mind, boom, the vertical line will be right here, right? And when will it be? At -6, 0, right? Yeah, pretty simple, straightforward stuff. Alright, I'm gonna ask y'all one last topic question and then we're done. Let's say we have the point AB. Point AB, where both A and B are positive, right? None of them are negative, right? So you can think about it like this. Point AB is somewhere around here, okay? AB. Alright? AB. In the first quadrant, alright? Where is A negative B? Where will that be again? We're tying it all back in together. A negative B would be, we're still at A, but negative B. So somewhere over here, right? This will be in quadrant form, or use Roman numerals now, right? Good. How about, that's another question. Where is negative A, positive B at? Okay, negative A. Well, if A is positive there, then negative AB would be, let's see, negative A, B. Somewhere around here, right? In the second quadrant. Alright, how about, I don't know what this one's going to be, negative A, negative B. Alright, that's going to be in the third quadrant, right? Negative A, negative B, somewhere around here, alright? And one more, where is BA? Good question. Well, you know, AB is in the first quadrant. If they're both positive, this is also be somewhere in the first quadrant, right? If maybe A is this wide and B is this tall, maybe they're the same amount, it'll probably be somewhere around here. I don't know, but it'll be in the first quadrant. So the answer for this one is quadrant 1. The answer for this one is quadrant 4. And the answer for this one, and negative AB was quadrant 2. Write it like this if you want. And then A was quadrant 1, negative A, negative B is in quadrant 3. Quadrant 3. And that's it, y'all. That is the end of part 1 of unit 2. Thank you guys so much for watching, and I'll see y'all next time for the next topic. See y'all soon.